Today is our review day for the test, and remember, wherever you stand with the homework, that's not nearly as important as getting ready for the test at this point. So I'm not telling you to drop everything and focus 100% on the homework, on the test if you're not done with all the homework. But I am saying to set that priority because this test is so much more important than a couple or three or even a whole homework assignment. You get 3 homework drops anyway. So just prioritize this test. So even if you're still working on some of the homework, please prioritize this test because it's going to be so much more important than any single homework assignment. So anyway, my intention today is to work through this. Also, I put a note up here when I was sharing to remind you to be sure to remind you that you're reading my emails because the testing procedures, and I'll probably send you another one sometime this afternoon probably this afternoon, and I may send you another one later. So keep up with those emails.
15.
15.
Yeah.
Okay. Does that look like the problem you want?
Yeah.
Okay, it says write the conditional statement in its equivalent disjunctive form. Now, when we studied this material in this section, I put up a slide that showed you the main important things you're going to have to remember from that slide. And one of them had to do with this formula here. It says the equivalent form of a conditional. There's more than that one thing. There were like 4 formulas. There were 2 De Morgan's laws, and then there's 2 of these similar. But you need to learn those 4 formulas. And as you're working through the homework or working through the test reviews, you can always look back at your notes, and you may not be learning the formulas. But when you get to the test, you're not going to have access to your notes. So be sure that you're learning these things so that when you get to the question, you'll have them. But in any case, when it says disjunctive form here, that tells you immediately that that's the formula you need. And at that point, you just match up your P's and Q's. So the original statement said if X is an irrational number, that would be like your P. If P, then X is not a terminating decimal, that would be like the Q. So if I'm matching it up to the formula, if I'm looking down to the lower left, I circle the P's in green and the Q in red. And that formula says you can take the left side of that equation and rewrite it in an equivalent form like the right-hand side. So when you rewrite it, you start out with the left-hand side and you're trying to convert it into the right-hand side. Well, the first thing on the right-hand side is the negation of P. So you'll see that that P changes to the negation of P. So if you go back up to that original statement, it says X is an irrational number. So the negation of that would be X is not an irrational number. So you're going up to this statement P, and you're noticing down here that you're negating it. So that becomes not an irrational number instead of it is an irrational number. Then the next thing you see is there's an or symbol. The V shape stands for the word or. So you have to write down the word or. And then the last thing on the right is just Q without changing it at all. Q is the statement X is not a terminating decimal. So you just write down X is not a terminating decimal. So I think once you get into the flow of what they're asking you to do, it's fairly straightforward. You start off with a sentence, you take that clue word disjunctive, and that tells you you're going to use this formula, and then you assume that what you've got on the left is the original statement, and you're going to turn it into whatever it says on the right, and what the right says is you take the negation of P, then write down the word or, and then just write down Q without changing it at all. Does that make sense?
Yes, thank you.
Okay. Anybody have another one they want me to tackle?
Just to confirm, what's like the answer to number 15?
That sentence. I mean, The only difference is they put the word either there. I guess I should have clicked again. That's just an English language grammar thing. Some people think if you put the word either in front of that sentence, it just sounds better. Logically speaking, it's not necessary. So the answer is that last choice. But that word either is just a filler word. It's just something that somebody said, well, it just sounds better if you stick the word either in front of it. But it's the only thing that could be. Even if you left off the word either right there, that's the important part. Either is just a filler word that makes it sound better to some people's ears. Does that make sense?
Yes, thank you.
So, oh boy, I've got lots of them. Awesome. The first one in that list, I'm going to try to do them in order, I guess. The first one in that list I see is number 8. So I'm going to stop sharing just a second, and then I'm going to get back to number 8, and then I'll go back through that list. All right, number 8. It says determine the truth value of the compound statement given that P is a false statement, Q is a true statement, and R is a false statement. So when you do these problems, you're thinking about a truth table, and if you've got P's, Q's, and R's, if you remember from our earlier work, when you have 3 statements, you have 2 to the third, you have 8 different rows in your truth table. So a lot of times you have to do the whole truth table. You have to do all 8 rows. But here, they're giving you what P is and Q is and R is, so they're actually telling you to only do 1 row of the truth table. So that's a good thing. Instead of having to produce 8 rows and do the whole truth table, you only have to do the row where P is false, Q is true, and R is false. So I would literally just plug in, everywhere I see a P, I just plug in F for false, and everywhere I see a Q, I would just literally plug in T for true, and everywhere I see an R in that expression, I would just quite literally plug in capital F. That way you can manipulate the truth values and just take it one step at a time. So if you're with me, what I did is I took every P out of the problem and put in a capital F because they told me P was false. Every Q I took completely out and replaced it with a T because they told me Q was true. And then I replaced every R with an F because they told me R was false. And now it's a matter of manipulating your symbols and using your rules, and you've got to do it in the right order. And one of the first things you want to do is anytime you see a tilde, which is the negation symbol in front of a letter, you just go ahead and flip it to its opposite. So if I were doing this, the very first thing I'd do is look at the not T and change that to an F, and take that not F on the very end and change it to a T. So anytime you see a tilde letter, it's probably easier just go ahead and get rid of the tilde and change it to its opposite.
Okay, I have a question.
Okay.
If the tilde is outside of parentheses, we don't change the letter?
Not until you get to it. You work from inside outside. The parentheses are telling you to do things in certain order, and you go inside the parentheses first, and when you get everything in the parentheses done, then you move to the outside of the parentheses. So it's like you're
thank you.
The parentheses are nesting symbols. They say go inside, do that first, and then you work your way out. And once you get out of the parenthesis, then you'll hit that symbol. So start on the very inside and work your way out. But now, bringing that up, you're ready to start working inside of some of those parentheses. So the first thing I notice is right here, you've got inside that first set of parentheses, you've got false anded with false. Remember, the upside down V is a symbol for and. And you have a memory device, or at least I hope you do, that helps you remember what the answer is. And for an and, my memory device is it's only true if they're both true. Well, not only are they not both true, neither are true. So if they're not both true, they must be false. So that immediately tells me with my little memory device that and is only true if they're both true. That tells me that false implies false must actually just be false. So you take that entire part up here and just change it into a false. And then you can do the same thing over here. You can work with this set of parentheses over here now, or you can keep working on the left. It's not necessarily a single order. You can do things wrong that the order is wrong, but sometimes you have a choice on what you want to do next. I actually, oops, I'm going backwards. I actually chose to go ahead and take care of the parentheses on the far right. And I know that that's an or symbol, and an or is only false if they're both false. Only false if they're both false. Well, if you look at that, false or true, they're not both false. Well, if they're not both false, the memory aid says it must be true. So what I've done now at this point is I've gotten rid of every one of my parentheses. I do have a big set of brackets. A bracket is just a fancy parenthesis, but we'll get to that soon enough as well. Trying to erase some of my extra stuff that I put on there so it's easier to look at. Is anybody lost at this point? Do I need to go back before I keep going? Does anybody have a question up to this point? Okay, assuming that you're done with, I mean, you don't have any more questions. The next thing I notice is you have a tilde in front of a letter now. So I can say, well, okay, a tilde in front of a letter means I need to change it to its negation, so not false is going to be true. And now I have another set of parentheses. It's actually brackets, but brackets and parentheses are the same thing. Brackets are just typically, it's just a visual difference. You can use brackets or parentheses. People usually use the interior things as parentheses, and if you're going to change, sometimes they use brackets on the outside. You can use parentheses all the time. It's just a visual thing. For all practical purposes, a bracket and a parenthesis is the same thing. So now we've got one set of brackets or parentheses left, and we've got to work inside of there. So the next thing I would do is look inside those brackets and realize that you're taking a true and you're ORing it with a false. And again, the memory aid for OR is it's only false if they're both false. Well, they're not both false. So since they're not both false, they must be true. And that takes me down to the very last statement. I'm down to the point where I just have true anded with true. Well, what's the memory aid for and? It's only true if they're both true. Well, they are both true. That's the only case an and is true, so the final answer would be true. So the trick here is to plug in the actual T's and F's, work from the inside to the outside, taking care of anything that's got a letter, but a tilde right directly in front of a letter, take care of that. Then work inside your parentheses, and then every time you get a letter with a tilde right next to it, then you've got to change it, and you just keep working your way out until you finally get to the end. Being very careful not to get your ands and or stuff mixed up. And is only true if they're both true, or is only false if they're both false. If you get those mixed up, you're probably going to miss the problem. Anything about that before I go on to the next one? Okay, I had a request for 8 through 12, so I just keep going. If you had a question, please stop me. You're not going to insult me or hurt my feelings if you interrupt me. This is exactly the same kind of thing. It's just a bigger expression. But they've told you P and Q and R, they told you the truth value, so they're asking you to do exactly the same thing. And you're going to see you got ands and ors. So I just went ahead and wrote the memory aids out. And is only true if they're both true. Or is only false or both false. Everything in that problem is either an and or an or. They told you that P was false. I'm going to literally plug an F in for P. They told you that Q was true, so I'll literally plug a T in for Q. They told me that R is true, so I'll plug a T in for R as well. If you do that, you get that. And in using exactly the same strategy we used before, anytime you see a tilde directly in front of a letter, you can flip it. So that not false becomes true, and that not true becomes false. So in your next step, you can just, and I would also say, don't try to do too much in your head. It's not going to kill you to write down your steps. And please, I'm going to say this because it's what we've done in the past, but we have not had an in-person test yet. But in the past, and I assume that's what's going to happen this time, the MTLC will provide you with scratch paper. Now they may decide, I'll send you another email for sure, but I think they're just figuring things out as they go with the pandemic stuff. But they may say because of the pandemic, they don't want to be handing people paper. So they may tell you to bring your own scratch paper, and they'll probably somebody examine it. I don't really know. That's why I said watch your email. I'll send you another email. So I would say right now, be prepared that you might be bringing in your own scratch paper, but don't be surprised if I tell you differently when I send you a new email. Again, I think they're trying to figure it out as they go right now. But in any case, please don't try to do this on your head on the screen. Just write things down. Write the whole problem down on your paper. Don't try to look on the screen and do it in your head. I think that's really a bad strategy. And don't skip steps. Take one step at a time, just like I'm doing here. In any case, now I'm ready to work inside. There are two sets of parentheses that are inside. So I'll just take the one on the left. The left one says true and true. Well, as we've discussed, an and is only true if they're both true. Well, in this case, they are both true. So it becomes a true. Then you look at the interior parentheses, sort of in the middle of the problem. It says false or false. Now remember, don't get your ands and ors mixed up. An and is only true if they're both true, but an or is only false if they're both false. Well, lo and behold, they are both false. Since they're both false, the result will be false. And now we're down to one last set of parentheses. Again, parentheses and brackets are interchangeable. So we're down to that last set of brackets, parentheses, whatever you want to think of it as, and that's an and. The memory aid for and is it's only true if they're both true. Well, they're not both true, so that means it's false. And that leaves us with an or. And the memory aid for or is it's only false or both false. Well, they're not both false. Well, if it's only false or both false and they're not both false, that means the result must be true. This is not difficult if you will learn your memory aids, practice a lot, take care of your tildes when they hit a letter directly, and start working inside your parentheses and work your way out one step at a time. Anything about that before I go on to number 10? Again, I'm recording this, so I should be able to put this up later so you can have it to go back and refer to if you need to. Ten is the first one where they're asking us to do the whole truth table. So in the other two problems, they were giving us the P's and Q's, or in that case, R's. Here, they're asking you to do a truth table, but luckily it only has P's and Q's in it, so there aren't 8 rows. There are only 2 to the second, which is 4 rows. And they went ahead and seeded it for you. They went ahead and told you that you've got 4 rows. It starts out being true, 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 false, false, true, and false, false for P. So literally, you've got to go fill out those columns. So I would just start and move across. One thing I would notice, and I also noticed that I've got ands and ors in the problems. You might want to go ahead and write down your memory aids for and or. And is only true if they're both true, or is only false for both false. And then just move across. I notice there's a Q column, so I take the values of Q right here, and I just move them over under the Q. So true, false, I just slide it over, true, false, true, false. There's also a not P. Well, P is true, true. If you look at the P column, P is true, true, false, false, but you're doing the negation of that. So you change trues to falses and false to true. So true, true, false, false becomes false, false, true, true. And you can go ahead and you can go all the way across and go ahead and put your not P in, or once you've got something on both sides of that symbol, you can just go ahead and evaluate that. This is a case where you have some flexibility. If you wanted to go ahead and if you wanted to go ahead and do the not Q column now, you could. In fact, I worked this on this PowerPoint probably last year. If I were doing it today, I probably would have gone ahead and done the not Q column next anyway. It doesn't matter. You have some flexibility in how you do these. But the way I did this slide, I went ahead and did the and. You can't do the symbol until you've got the values on both sides. But as soon as you've got the values on both sides of it, you can do it. And remember, the and is only true if they're both true. So you scan down those columns and you look to see if there's any place where they're both true. And if you notice, There's the only place where they're both true. That's true and that's true. If they're both true, then the answer is true. Nowhere else are they both true, so that means they're false. And then you keep moving. Now notice, in order to do a symbol, like I can't do this or yet because you've got to have something on both sides of it to do it. Well, I have something on the left side of the or, but I don't have anything yet on the right side of the or. So you have to get that right side filled in first before you can do the symbol. But that last column is a not Q. So you can go back over here and look at the Q column and just change them all to the opposite. So the Q column is true, false, true, false. So when you move it over, it becomes false, true, false, true. And now that you've got something on both sides of that symbol, you can evaluate it. And it's an or. The memory aid for or is it's only false if they're both false. Well, you can see that the very first line is both false, but none of the rest of them are both falses, so the rest of them must be true.
I have a question.
Okay.
So how did you get the original true and false letters for the first two rows of
They're
what
given to you. They're given to you.
Oh, okay.
11 says to take these two truth tables and show that they're equivalent. Now, anytime someone asks you to show two things are equivalent, unless you've got some additional knowledge, and we have learned some things about certain statements to figure out their equivalent right away, but unless you have that specialized knowledge, the standard way of showing that two statements are equivalent is to do the truth table for both of them. So they're asking you to take the truth table for this bigger expression, this more complex expression, P or the quantity Q and not P. So they made a truth table. This is the truth table for that. And then they took the other statement, P or Q, and made a truth table for that. And what they're meaning is this true over here goes all the way across. So they didn't put a column PQ and put. They could have put that. They could have done that. But they're just assuming you're going to look back over here and see that that's a true false, and that's a false true. So they didn't copy those first two columns down again. They're just assuming that you're going to look way back over here. So when you get to the second one, you're looking back at those first two rows to get that. Anyway, basically they just want you to do two truth tables. So we'll start with the bigger one. And let me erase all the distracting stuff I wrote around it. So I'm doing the truth table for that first statement. I just copy the P column. There's a P column on the left. The first column that's blank is a P column, so I just copy down. The P is true, true, false, false, so I just write in true, true, false, false. Please write this down on your paper. Do not try to do it on the screen. I promise you, you'll be better off. You can't evaluate a symbol until you have something on both sides of it. So there's nothing you can do with that second column that says or until you get something on both sides of it. But I do know that the Q column is true, false. I know the Q column is true, false, true, false. And I have a Q column right here. So I just write down true, false, true, false. And then you got to be careful. The parentheses don't go around the first two. So you're not going to do these together because the parentheses are around these last two. So one of the mistakes you can make if you're not careful is to ignore the parentheses. If you start doing this or right here now and try to do it in here, that's wrong. That's completely wrong because the parentheses tell you to do these two first. So you've got to do these two first. You've got to do these two before you can do that one. So the parentheses mean something. So if you see parentheses, you have to obey the parentheses. The parentheses says, no, don't do that yet. Go over and do the stuff in parentheses first. Well, in order to do the stuff in parentheses, I've got to know what not P is. Luckily, I do know what not P is. P is true, true, false, false. So not P is false, false, true, true. Now that I've got something on both sides of this and, I can now evaluate it. And again, the rule for and is it's only true if they're both true. And if you look, there's no place on either side where they're both true. So there's going to be a whole column of falses. And again, once those two columns were used, it might not be a bad idea just to scratch them out. Once they've been used, they were used to produce this. They've been used up. They're gone. So now I'm ready to do the OR, and I'm going to use this column and this column along with my OR. These two columns got used up. So I'm going to use OR, and the shortcut for OR is only false or both false, but I'm looking here. Well, if I take true and false, that's not both false. If I take true and false, that's not both false. If I take false and true, that's not both false. The only time I get both false is the very last row. So that's going to be my only F in the whole column, because that's the only place where you get a false and a false. Are you with me so far? And the last column you do is kind of, I would think if that's the answer. The last column you did is sort of the answer. That's the answer to that table. The very last column you did, because see, now that column and that column are used up. So whatever, the last column you produce is sort of generically, you say that's the answer that you're looking for. So what you've got to do now is go over here and see if you get the same answer. Well, the second one is very simple. It's just got a P on the left and a Q on the right. So you put down true, true, false, false for P, and see, P is true, true, false, false. So you copy that down. And Q is true, false, false. You copy that down. And now you do the OR, and the OR is only true if they're both true. And if you look at the OR, the first row is both true. The second row is only one true, but remember, it's only false or both false. They're not both false in row 1. They're not both false in row 2. They're not both false in row 3, but only in row 4 do you get both falses. So the answer, if you want to think of it, these two columns got used up by producing this one. So this is kind of the answer for this column. So your question is, does the answer on the left equal the answer on the right? If they do, they're equivalent. And on the left, I got T, 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 F. And on the right, I got T, 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 F. So the answer is yes, they're equivalent. If there's anything different about those last columns in each table, then they're not equivalent. But they turn out to both be T, 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 F. So I can say yes, they are equivalent. And it actually didn't say yes or no. It just said to show they are. They were saying they were equivalent. They just wanted to show it. So your final answer is not really yes or no. Your final answer is is all these things you put in your table.
Professor, I'm still really confused about like the last part of the tables of when you're determining the symbols, the and or symbols, columns. I'm so confused. How exactly do you know what you're comparing? Because I was under the impression that you would just compare with like what was in the two columns next to it.
Well, you are to some degree, but you have to pay attention to the parentheses. You can't just go willy-nilly and go left to right. You have to, your parentheses are telling you things that are important. So if you go back to this problem, I see these parentheses here. So I'll just say, okay, I'm going to do those first. So I say, I'm paying attention to those parentheses. I'll go ahead and do them first. But in order to do the parentheses, I know it's going to be an and. I've got to figure out what's on both sides. Well, the first on the left is easy. It's just Q. So I literally go to the Q column and I just copy it down. So I get true, false, true, false. Then when I get over here on the right side, I've got to have the negation of P. So I don't want to copy down P. I want to copy down the negation. I want to get the not P. So instead of being true, true, false, false, it becomes false, false, true, true. So are you with me so far?
Yes, sir.
Now, if those parentheses are confusing to you, it might be helpful to actually even just copy them down. Those parentheses are literally there. Whether you actually write them down or not, those parentheses are there, at least understood. And so what I'm doing is I'm doing an and on every one of those. So I've got an and in this column right here, I've got to do an and with true or false. Well, what's the shortcut for and? For and, which is a V, it's only true if both are true. So when I'm doing that, the only time I see both trues is right here. That's both true, so that's going to be true. There's no both true anywhere else, so that means everything else is going to be false. So are you with me there?
Yes.
Okay. Now I'm ready to move out. Or I can go ahead and evaluate. You have some flexibility, but since we've already evaluated these, I didn't say that the way I meant it exactly. Once you've used up the columns, it might be helpful to just sort of ignore them. Once they've been used, these two columns produce these two. So in a sense, now you consider those two columns as being used up. So you don't even, you pretend like they're not even there anymore. Of course, you enter the answer on screen, but for purposes of moving forward, they've been used up. It's like the parents had the kid. That and now is the kid. The parents are passed away. They're gone. All you got left is that middle row, middle column, which is the kid, I guess. So what you've got now is simply the P column ORed with this column that remains. So now I got to type in that P column. Well, the P column is just true, true, false, false. So I go over here and I type in or enter in true, true, false, false. That's the P column. Are you still with me?
Yes.
Okay. Now, all that's left, in spite of the fact that stuff is sitting there, all that's really left I'll make it highlighted so it stands out more, is this column on the left side of the OR and this column on the right side of the OR. So now you're taking those two columns, you're pretending like nothing else existed, nothing else exists, and you're doing an OR for it. Well, again, the shortcut, the memory aid for OR is only false if they're both false. Well, if you look at those two, the only time they're both false is the very bottom. So that becomes false. Nothing else is both false, so everything else must be true. Does that help you at all to see how you do that order? The parentheses forces you to do things over here on the far right and kind of get an answer before you can do the stuff on the left.
Yes, that was helpful. Thank you.
And then, of course, I won't belabor the point, but once you use these two columns to produce that middle column, they're kind of gone too. So this is what you're comparing. When you do this one over here, you're going to be comparing this column to that column. Okay. Well, anyway, that's very helpful though to see where you're struggling, so I can try to bring you up from that point. So let's see if that helps on number 12. On number 12, we have two sets of parentheses. In fact, we got brackets with parentheses inside of parentheses. So it's kind of and again, you have some flexibility about how you get started. As long as you don't violate what the parentheses are telling you to do, you have some flexibility. But the first thing I notice is the first column is P, and I can just throw that P in there. P is true, true, false, false. So I just copy in true, true, false, false. I see another P way over there, so why not go ahead and do that too? There's another P way over there, so I'll do true, true, false, false as well. And I see a Q. There's a Q column. That's true, false, true, false. So I just type in true, false, true, false. And there's also a not Q column. So I can take the Q's and just change them to their opposites. And that true, false, true, false becomes false, true, false, true. Now, you can do that kind of in any order you want to, but at this point, you cannot ignore the parentheses anymore. You've got a set of parentheses here, and you've got an inside set of parentheses. You've got to get those done. When you're working with nested parentheses, you've got to do the inside set of parentheses before you do the outside set. So I've got some flexibility. I could go ahead and do this first, and then I could do this, or I could do this one first and then do this other one. They're both inside of parentheses, so I've got a little bit of flexibility. In fact, I did this like a year ago, so let's see which way I chose to do it. I decided to go ahead and go back to the left. As long as you have something on both sides of the symbol, you should be able to do it. Well, the symbol is an and the shortcut rule, the memory aid for and is it's only true if they're both true. Well, if you look through that list, there's only one place where they're both true. That's going to be the only true in the column. Everything else will be false. And again, if you're doing it on paper, once you take two columns that produce another column, you can kind of just mark them out so they don't confuse you anymore. This is the only column that's important now on the left side. Now I can jump back. I still have these parentheses over here. I have to deal with the things inside those parentheses before I can move out. You got to take the inside of the parentheses before you can expand out. So I want to do this and column. And the and memory aid is they're only true if they're both true. In fact, the other one was an and as well. Well, there's only one place where they're both true, and that's the first row. They're only both true there. So you get true, false, 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 false. And again, once you've used up, once the columns produce another column, that's like the parents having the kid, I guess. Only the kid matters at this point. But you do have one more set of brackets or parentheses. You've got to deal with these. Again, parentheses and brackets are just visually different. Logically, mathematically, they're the same thing. You don't have to ever use brackets. You could just use more parentheses. It's just a visual thing. So now you're at those outside parentheses, and what you see, or outside brackets, what you see is a not. So this not column is going to be the negation of what you just did over here on the far right. So now it's saying I have to negate that and column. So I'm going to go over here and I'm going to take that true and make it a false. And I'm going to take that false and make it a true, and take that false and make it a true, and take that false and make it a true. So when I negate it, it goes over there. And again, I just used that column up, so it's gone. I guess that's a single parent. It only took one column to produce that other column. A negation doesn't require two columns. If you're doing an and or an or, you've got to have something on both sides, but a negation only requires one column. So now you're left with this column and this column, and they're going to be done. They're an if-then. They're an implication. The right facing arrow, the right pointing arrow is an implication or an if-then. So I don't think we've done an if-then yet. So I've got to remember the memory aid for the if-then, and to me that's the hardest one. I cannot find a cutesy way to remember it. So all I do is I remember there's only one time when an implication is false. It's only false if it's got a true on the left and a false on the right. I don't know a cutesy way to remember that. I just have to straight memorize that one. It's only false when you got a T followed by an F, a T on the left side of the arrow, F on the right side of the arrow. So if you look at it, is there any place where you have a T on the left and an F on the right? Well, here you have an F on the left and an F on the right. That's not the case. Here you have a T on the left, but you also have a T on the right, so that doesn't fit the one case. Here you have a F followed by a T. That's not the case. It has to be T followed by F. And here you got an F followed by a T. So there is no false then. There's no place where it's false. So that means you're going to have a whole set of truths.
I have a question.
Okay.
My internet went out when you were saying with the negation. So whenever you do the negation that's in the brackets, you would just go for the opposite of what's in the middle?
It's the opposite of the middle part right there.
All right. Got you. Thank you.
Sure. And then once you've done it, it's used up. Once you take once a column is used to produce another column, then it's used up. I kind of think of it like it's gone away. It's still there, but you don't want to focus on it anymore. So easiest way not to focus on it is kind of just mark it out so your eyes doesn't accidentally catch the wrong column.
So what is the kind of rule for the if then or the arrow symbol?
Well, it's just this. It's only false in one case. If it starts off being true on the left of the arrow and false on the right of the arrow, that's the only false case. I don't have a cutesy way to remember it. I just have to straight up memorize that. I say that's the only case it's false. You can make up an example, like you say, if it rains and I'll take my umbrella. The only time that statement will be false is if it did rain but you didn't take your umbrella. That'd be true implies false. So if you said the statement, if it rains then I'll take my umbrella, the only way somebody could say you were lying is if it did rain but you didn't take your umbrella. That's true implies false. I don't really have a cutesy way to remember it. I just have to memorize that case. All right. Gosh. Somebody wanted 13, so let's move along to something different. We've spent so much time on truth tables, but which is not a bad thing because it takes practice. It says determine the truth value of the given statement. If all vegetables are orange, then peaches are vegetables. Now here you have to know a little bit about real life. For example, are all vegetables orange? I would say no. So that'd be a false statement. Can't you think of plenty of vegetables that aren't orange? So that's a false statement. Are peaches vegetables? No, I don't think. I think peaches are fruits. So that would be false. And then you've got an if-then. With an if-then statement, remember that little rule. I couldn't remember a cutesy rule, but it's only false in one case. It's only false when you see this. Well, that's not what this is. Well, if that's the only time it's false, then the other cases must all be true. So it's just true. You just have to remember there's only one time where an if-then is false. That's if you get this. If you get a true on the left of the arrow and a false on the right of the arrow, that's the only time an implication is ever false. As long as it's anything besides true implies false, it's going to be true. So don't overthink it. That's the one case where you just have to memorize the case that's false. Someone asked for 17, so let's see if I can shoot to 17. What I will say about some of these problems, you do not have to make 100 on a test to make an A. So some of these problems are kind of trying to test the people who are really, really into this and really understand it. This is one of those problems that kind of gets down into the weeds. I wouldn't stress out too much about it, but I will go over it. And there's a key to understanding whether it's going to be right or wrong. And I think maybe I can explain it to you. And once you understand it, you almost, if you see a problem like this, you know what the answer is going to be, is what I'd say about it. So if you look at this problem, this is an if and only if. It says x squared is equal to 4 if and only if x is equal to 2. But what you got to remember is, if you studied your algebra back in junior high school or high school, whenever you took algebra, you probably remember that if x squared is equal to 4, there's actually two answers, not just one, because x squared equals 4. If you put 2 in for x, you get a right answer. If you put a negative 2 and square it, negative 2 times negative 2 is also 4. So there's actually two answers. So I would say think of x squared equal 4 as being two separate statements of saying x is equal to 2 or minus 2. Now look at this. This says x is equal to 2 or minus 2 if and only if x is equal to 2. But there are two answers on the left and there's only one answer on the right. That's going to be false every time. So I would just remember, if you've got an if and only if where it has one number of answers on one side and a different number of answers on the other side, it's going to be false every time. It doesn't have any hope of being true if you don't even have the same number of answers. So this can be hard to understand if you really wanted to delve down into it, but on the simplest level, I would just say if you see a problem with an if and only if and there's two answers on the left and only one answer on the right, it's going to be false every time. That's how I would look at it. And that way you don't have to spend so much time analyzing the down into the weeds. You can just see from a big picture point of view that if you got two things on the left and one on the right, there's no way the statement's going to be, those two statements can't be equivalent. All right, I was looking, I'm trying to get everything in everybody's asked about. Somebody asked for 28, so let me And as I'm paging through some of these things, if you see these on videos later and you want to pause it, you'll be able to see at least some of the answers on some of these things, even if I didn't talk about them. Okay, 28. This has to do with the Euler diagrams. Now, this is one of the lectures that you had a video to watch. It was me, of course, but I'm also sending you a link of another instructor talking about the same material. So sometimes it helps to hear how somebody else says it. So one of the links I'm going to send you this afternoon is I'm going to take my lecture and take her lecture, and I'm going to tag them all into one file, one video, and I'm going to send you that link. And you could actually watch me do it and then watch her talk about the same topic, and it might make more sense when she says it than when I say it, or vice versa, but it gives you another option. But anyway, this is one of those, this is I think a 3-6 problem where you would have watched the video. It says all frogs are poetical. Kermit is a frog, therefore Kermit is poetical. This little stacked set of balls there means therefore. So you've got two premises. One premise is that all frogs are poetical, which I don't exactly know what that means. I guess they like poetry. And Kermit is a frog, therefore Kermit is poetical. The thing about a logical argument is that the two things above the horizontal line are called the premises. Those are the things you accept as being true. Even if they're not true, you're accepting them as true. So do you think all frogs are poetical? Well, you probably don't think that. But for the purposes of a problem, a premise is taken as face value being true. Even if you think it's not true, we're assuming it's true. So we're assuming that all frogs really are poetical. That's an assumption we're going to make in this argument. And we're also assuming that Kermit is a frog. And we want to say, knowing those two premises is the conclusion. The thing under the horizontal line is called the conclusion. These are the premises, and this is the conclusion. So if the premises are true, if they're true, does the conclusion follow? And this is where we found, if you watch the video, these things called Euler diagrams, and that word is actually Euler. I don't think anybody that's never have studied math or know who this person is probably doesn't pronounce it, but it's Euler. These Euler diagrams help you figure it out. So what I did is you could write the words out. I just used F for frog and P for poetical. And we're assuming that all frogs are poetical. So if you look at that in an Euler diagram, that means that the frog circle is inside the poetical circle. If all frogs are poetical, if you put all frogs inside the inside circle, if they're all poetical, they've got to be inside the poetical circle. So when you say all of something is something, that means that it's inside of a bigger circle. So that's one of the things about Euler. When you say all of something is something, that means that thing goes inside of a bigger thing. So that's the Euler diagram for the statement that all frogs are poetical. The F circle representing frogs is inside the poetical circle. So now look at Kermit. Kermit's a frog, so I put a dot for Kermit. If Kermit's a frog, Kermit has to be inside of the frog circle, right? If Kermit were a dog, the dot could be somewhere else. But if Kermit really is a frog, which is our second premise, that Kermit really is a frog, then Kermit, represented by that red dot, has to be inside the frog circle. If it had said Kermit is a dog, that red dot could be anywhere. But if you know that Kermit is a frog, then that red dot representing Kermit has to be inside the frog circle. So are you with me on the setup? I've taken both of those premises. I've taken both of the premises and I've turned them into an Euler diagram. Now I'm going to use that Euler diagram to see if the conclusion makes sense. So if you know that Kermit's a frog and that all frogs are poetical, does it absolutely 100% have to follow that Kermit is poetical? In other words, Kermit's inside the frog circle, but everything in the frog circle is also inside the poetical circle. So not only is the red dot inside the F circle, but since the F circle is completely inside the P circle, the red dot's also inside the P circle. So that means that if you accept the fact that Kermit really is a frog and that that red dot belongs inside the frog circle, that red dot is also inside the poetical circle, which means Kermit must be poetical too. So that would be a valid argument. You're arguing from the premises. And so as long as that dot stays in the frog circle, it can't get outside the P circle. It's like a concentric fences. If the dot can't get outside the inside fence, it can never get outside the outside fence. And the outside fence represents the people that are poetical, are the things that are poetical. So that means that that is a perfectly valid argument. If you accept that all frogs are poetical and you accept that Kermit's a frog, then it inevitably follows that Kermit must be poetical. And so that's a valid argument. Does that make sense? You kind of get into the flow of these things as you work through them, and you use these diagrams. And so, and luckily for you, they're asking you to pick it out of a list. So you're actually picking it out from A, B, C, D, and you can kind of go through and eliminate stuff. If you say, well, that doesn't make sense, you can mark things out, and then you're just left with one. Well, it's got to be, if the other three don't make any sense, it's got to be that one. So sometimes you can do that kind of thing too. I think 29 is the same sort of thing. So let's do another one. We're getting close on time. I think the next person is probably going to be coming in for their class in a little bit. So that's why I'm trying to get these done that people ask for. Okay, 28, another Euler diagram. Again, the premises are that all fish can swim. And the conclusion, the other premise is that barracuda can swim. And the conclusion is, therefore, that barracuda is a fish. Is that valid or invalid? So you start off with your premises. The premises are true. You assume they're true anyway. So one says that all fish can swim. So I'm going to put F for fish, and I'm going to put S for swim, can swim. You can write out the whole words if you want to, but in fact, the problems, the answers do write out the whole word, but I just went ahead and used F for fish and S for swim. And because the first premise says all fish can swim, if all fish can swim, then the fish circle must be completely inside of the swim circle. If it just said some fish can swim, then there could be an overlap. Part of the fish circle might not be inside the swim circle. But if it says all fish can swim, the fish circle has to be inside the swim circle. And then it says that barracuda, that particular barracuda. So you've got a barracuda you're looking at. You're pointing at this barracuda. You're saying that barracuda can swim. So I'm going to put a dot to represent that barracuda. Well, if that barracuda can swim, all we know is that the barracuda is inside the swim circle. Now, you may know from studying fish or from being a fisherman, you may know that a barracuda is a fish, and you say, well, that dot has to be in the fish circle. But the premise doesn't say that. And barracuda is also, at least it was at one point, the name of a car too. So maybe they're talking about a car, not a fish. But anyway, there's nothing in the premise that says that barracuda is a fish. If you think barracuda is a fish, you're thinking outside of the information you're given. You're not given what a barracuda is. A barracuda is just something that can swim. I mean, maybe it's a car, maybe it's not a fish. Anyway, you don't know for sure that that barracuda is a fish. It might be. It might be there. It might not. That if the barracuda is a fish, the dot's going to be inside the fish circle. But if the barracuda is not a fish, then that dot's going to be in the swim circle because it says the barracuda can swim. But it doesn't say that it's a fish. So you can't be sure that that barracuda is inside that fish circle. It might be, might not be. So you don't know for sure. That dot could be inside the fish circle or not. Well, what does the conclusion say? The conclusion says that barracuda is a fish. Well, we just said we don't know. Maybe it is, maybe it's not. Maybe it's a car called the barracuda. And anyway, the thing that proves it's not valid is the case where it would not be in there. If that dot were not inside the fish circle, that would be the case that proves that the conclusion is not valid. So the answer choice you want to pick over here on the right is the one that shows that the argument's not really valid. And that's this one. That the dot, I used a red dot, they used a black dot. That black dot is in the can swim circle, but is not inside the fish circle. It's like this one. That's the dot that proves that argument is not valid. if that fish, if that barracuda is in fact not a fish, it could be out there. That's the case that proves that the argument's not valid. And there were two more, 30 and 31. I'm going to go through those real quickly. If you have some other problems later, you can email me about them and do some screenshots, and I can try to help you over email, or we could even set up an individual Zoom. But I do want to at least get through the ones that people ask me about before the next instructor takes over the classroom. Number 30, another Euler diagram. It says some plants have flowers. All things that have flowers are beautiful. Those are the premises. That's what you're assuming to be true. And the conclusion would be therefore some plants are beautiful. And you want to know if that argument's valid or not. So you start with the premises. I'm going to use P for plants, F for flowers, and B for beautiful. You can just write the words out like they did if you want to. Perfectly okay. But I just like to use letters. It takes up less room. So the first premise says some plants have flowers. So that's like this. It doesn't say all plants have flowers. If all plants had flowers, the flower circle would have to be completely inside the plant circle. If all flowers were that's wrong. Let me say that again. If all plants have flowers, the plant circle would have to be completely inside the flower circle if all plants have flowers. But it doesn't say all plants have flowers. So if you don't know that all plants have flowers, you've got to allow the possibility that maybe some plants don't have flowers. And if you're saying some plants might not have flowers, you've got to let those circles overlap. These will be the plants that do have flowers, and these will be the plants that don't have flowers. So when you say some of something, you're usually using overlapping circles. When you say all of something, one circle's inside the other. When you say some somethings or somethings, they overlap. They allow for the possibility, but don't force it. The second premise says all things that have flowers are beautiful. So you need a beautiful circle. So all things that have flowers are beautiful. So that means that the flower circle is inside the beautiful circle. If all things that have flowers are beautiful, that means that the flower circle must be inside of a bigger circle that's for all the beautiful things. So I've had to throw in a third circle there. Now look at the conclusion. The conclusion says, so some plants are beautiful. So think about the idea of putting a dot to stand for a plant. We know that some plants have flowers, and the flower circle is completely inside the beautiful circle. So if you take that dot representing let's see, some plants have flowers. All things that have flowers are beautiful. So that dot has got to be, and if you're looking at plants being beautiful, it doesn't say all plants are beautiful. If you were saying all plants are beautiful, you'd say that's invalid, because you could have a plant over here that wouldn't be inside the beautiful circle. But it doesn't say all plants are beautiful. If it said all plants are beautiful, that'd be invalid. It just says some are beautiful. Well, there you go. There's some plants that could be beautiful and be a plant. So you got to pay attention to the words. If it had said all plants are beautiful, that argument would be invalid. But because it just said some plants are beautiful, you can find a way to put a dot that's in a plant circle and a beautiful circle. So that argument is in fact valid. So you have to pay really close attention to some versus all, things like that as you're working these problems. And the last one somebody wrote down was 31, so at least I'll get to that one. It says use an Euler diagram to determine whether the argument is valid or invalid. Same sort of thing. It says no mathematics test is fun. All fun things are worth your time. Therefore, no mathematics test is worth your time. So the two premises are above the horizontal line. I'm going to use M for math test, F for fun, and W for worth your time. I'm going to go back to that first premise. It says no math test is fun. So if you look at your circle, you can't let them overlap, but it says no math test is fun. I hope you disagree with that. And I don't know if you're going to think a math test is fun, but I guess some people might think it's fun. But that says no math test is fun. So that means the math circle the math test circle and the fun circle cannot overlap at all. They've got to be completely separate. So that's how you draw that. The second premise says all fun things are worth your time. So that means that the fun circle is inside the worth your time circle. Everything that's fun is worth your time. So the fun circle has to be completely inside the worth your time circle. We know that no math test is fun, and the fun circle's got to be inside the worth circle. So you got a picture like that, worth your time circle. So what about the conclusion? Well, the conclusion said no math test is worth your time. So the question really becomes is, does the math circle can't overlap with the fun circle, but could the math circle overlap with the worth your time circle? Well, it's nothing in the premise that says it can't. So even though I first drew the math circle completely outside the worth your time circle too, there's no reason for me to draw it that way, because there's nothing in the premises all it said is that the math circle and the fun circle can't overlap. It didn't say the math circle and the worth your time circle can't overlap. So it could look like this, but it could also look like this. As long as the math circle and the fun circle don't overlap, there's nothing in the premises that says the math circle and the worth your time circle can't overlap. So is that argument valid or not? Well, if you think about putting a dot, if you look at it on the right, it's not possible to logically prove that no math test is worth your time, because you don't know, is that dot going to hit inside the worth circle? Well, it could, or it could not. Even if you use this right diagram, the dot could be here. So it says no math test is worth your time. Well, I'm not sure. If you were using this diagram, that would be true. No math test would ever be worth your time if you were looking on the left. But if that math circle and your worth your time circle happen to overlap, there would be a math test that's fun, and that would invalidate your argument. So it says no math test is worth your time. I found a case where a math test would be worth your time. In fact, it'd be that second choice up there at the top with it, where you could have a math test that was worth your time. A lot of this stuff is practice makes perfect.
All right. Hi, guys. So today we're looking at a review for test 2. And before I get started, I do just want to emphasize that this is not a comprehensive review. The comprehensive review is going to be what you see in WebAssign. But this will go over the main kind of concepts that you should worry about. And so first, let me start with putting together a kind of formula sheet that you can use to study. And so the topic for this test was logic. And so we started by learning all of the different symbols in logic. So first we had a squiggle and then a P, and that translates to not P. And then we had P upside down V Q, that meant P and Q. And then we had P V Q, which meant P or Q. So those symbols look kind of like the intersection and union symbols that we had for sets. And then we had P arrow Q, which meant if P, then Q. And finally we had the double-sided arrow, which meant P, if and only if, Q. So these were the symbols that we had for this test. And then after we learned all of the symbols, we went ahead and started looking at truth tables. And so let me put all of the truth tables that you need to know together in one place. So remember, the truth tables always start with your P and Q. And P is true true, false, false, and then Q alternates, true, false, true, false. And those would always be given to you in the tables on the test or the homework. And then let's write the table for P or Q, P and Q, and then if P, then Q. So again, we've got or, and then if P, then Q. So there's different ways to remember each of these tables. The way that I generally remember the or and the and tables is that for or, true wins. In other words, you just need one statement to be true, and that will make the whole statement be true. And then for and, F wins, where you just need one statement to be false for the whole statement to be false. So if I said today is Thursday and today is Friday, that would have to be a false statement because at least one of those things has to be false. Okay. All right, so let me fill in those tables. So for or, true wins, and so any row with a T will have T as its answer, and so only the last row has a false. And then the and is kind of the opposite, where there's only one row that's true, and then every other row has a false in it, and so the whole thing is false. And then lastly, for the if P then Q, that's going to be T, F, T, T. And so the way I remember this table is to just remember the false one. So there's only one false in that column. And so what this says is that the only way in which the statement if P then Q is false, the only way for that statement to be false is in that one particular combination where you have T going to F. So in that second row, P is true, Q is false, and the if P then Q statement is false. So that's if the hypothesis happens and the conclusion does not follow. Okay. So those are all of those tables. There was one more type of statement where we looked at the truth values, and we didn't really draw a table for it, but we still discussed the truth value of it. So we talked about the truth value for P if and only if. Man, I cannot write today or spell. P if and only if Q. There we go. So that statement is true when P and Q match. Okay, so in other words, if both P and Q are true, or if both P and Q are false, then that statement will be true. And so basically the statement is true if P and Q say the same thing. Okay, so that's all of those truth tables and analysis of the truth values of a statement. Okay. All right. So then the next kind of notation or formula kind of thing that you should know is the 4 different statements that we discussed. So we talked about the conditional, we talked about the converse, we talked about the inverse, and then the contrapositive. So we had these 4 statements that were in a specific format. So the conditional is of the form if P then Q. So it's kind of like our regular statement. The converse is where you switch the order. So you have if Q then P. The inverse is where you negate the statement. So you have if not P, then not Q. And then the contrapositive is where you flip the order and negate at the same time. So you have if not Q, then not P. All right. And we also talked about the equivalence of these statements. So we said that the conditional and contrapositive were equivalent. They were logically equivalent. They said the same thing. And the converse and the inverse were also equivalent. All right, so we had those 4 statements that we needed to know how to write. And then I'm almost done with this page. For the conditional, remember we also had some other ways of writing if P then Q. So some other forms that mean the same thing. You can have Q if P. You can have Q provided that P. You can have P only if Q. And you can also have every P is a Q. So all of these are equivalent ways of saying if P then Q, and just depending on the English of the statement, really. We pick one or the other because it sounds better. So you want to remember those formats of those sentences, and also especially remember the order of Q versus P. Notice those are in different orders. Okay. Now, the very last thing that you'll need to know, which I'm not going to write here, is just to know the 9 logical fallacies. So for those, all of those specific definitions are in the notes, so you can look at those logical fallacies in the notes and memorize them there. Okay, so those are all of the things that you would want to kind of memorize for this test. And I guess it's more vocab than like a formula, but all right. So let's finally do some problems. So the first problem is about translating a sentence. So we want to write the sentence in symbolic form with this P, Q, and R. And so the sentence says, if I order food and eat too much, then I will not feel well. And so we just want to basically translate the sentence one part at a time. So the I order food part is Q, and is my upside down V. Eating too much is P. And then notice that I have a comma here. And what a comma does is it tells you to group using parentheses. So in other words, the Q and P is its own little block. And so we're going to put parentheses around it. Okay. Now I have an if-then statement, so I'm going to use an arrow. And then not feeling well is the opposite of R. So I'll put squiggle R. So if I put that all together, I have Q and P going to not R. And that's the translation of that statement. Okay. So you want to know all the symbols and know what they mean. All right, so now let's do a problem where we have to determine a truth value. So we're given P is false, Q is true, and R is false. And so we can use those values to plug in to the statement. So first I'll go ahead and write down what not P, not Q, and not R should be. So I'll just flip the values. So I'll have T, F, and T. And now that I have all of these values, I can just go ahead and plug them into the sentence. So I'll plug in the values. So not P is true, Q is true, and then P is false, and not R is true. So this is the statement that I'm putting together. And let's just remind ourselves what all of these symbols mean. So I have or, and another and. Okay. And so now you want to go ahead and do the stuff in parentheses first. So you follow order of operations. So first I'll look at T or T. So remember, for or statements, true wins. So this whole thing is true. And then for the F and T, remember, for and statements, false wins. And so one false statement makes the whole thing false. So I've broken it down to just true and false. And again, one false statement makes the whole statement false. So this would be a false statement. Okay. So there's a problem where you have one specific combination and you're finding the truth value for that one combination. The next one that we're going to do is where we have an entire table and we're filling in the whole table. So maybe before I do this specific problem, I'll just remind you of the steps in which we fill in the table. So first of all, the first step is kind of the gimme step. So step one is going to be to fill in the letters. So fill in P, Q, not P, and not Q. And that one, you're just basically copying down what they already have given you. So this part of the truth table should be the easy part. All right, and then step two is going to be to fill in all of the other symbols, whatever they may be. And finally, step three is going to be to get the final column. And the way in which you get the final column is you combine the most recent answers. So the order in which you fill in the table is important. And so for that last column, you combine the most recent answers. Okay. So let's go ahead and go through that process for this table. So it's always going to be formatted in this way, where they give you the statement and then they kind of give you your template for your table. So let's do step one, which is to fill in all of the letters. And remember, the not symbol means we're going to flip the truth values. So P is given as TTFF. Okay. Not Q is going to be the flip of the Q column. So instead of TF, I'm going to have FT. And then I have TTFF again, and then Q is TF. So with this, notice I've already filled in over half of this table. So the first step is pretty significant and it's not too difficult. Okay. All right, so now we have to go ahead and fill in the other columns. So we have an or symbol and an and symbol, where, remember, let me use a different color. Use green again. So we have or and then remember I said for or, true wins, and for and, false wins. And we're going to do the stuff in parentheses first. So follow order of operations. So first let's do the arrow. So remember, for the if P then Q, if you go back and reference our first page, the only way for this to be a false statement is if the first thing is true and the second thing is false. So that's the case for that first row. But for any other combination, the statement is true. So what we're doing here is we're combining these outer two columns to get the middle. Okay, and then let's do the same kind of thing for the and symbol. So for and, false wins, which means any row with a false is overall false. So that's going to be those bottom 3 entries, but the top part is true. Okay, so that's step 2. That's filling in the symbol columns. And step 3 is going to be to get that final blank column. And again, what we're going to do is use our most recent answers. So I'm going to combine the 2 red columns into this middle blue column. And for or, true wins. So we just need 1 red T to make the whole thing true. And there's actually a T in every single column, or row rather. And so the final column, which is the overall value of the truth statement, is actually just all true, all T's. Okay, so that's an example of filling in a truth table in that step-by-step process. So I think one of the hardest things is just figuring out which columns combine into your current column. Okay, so now let me zoom back in. And so let's take a look at a couple sentences. And they want us to determine the truth value of these sentences. And I wouldn't think too hard about these questions. So they're not meant to be trick questions, is kind of what I'm getting at. So what we want to do here is determine the truth value of the individual components of the sentence and then see how that gets put together. So for the first sentence, we have if Tuscaloosa is the capital of the US, then penguins can fly. Okay. All right. So Tuscaloosa is the capital of the US. That is a false statement. So we're not even the capital of Alabama, so we're definitely not the capital of the United States. And then penguins can fly. That is a false statement. So we have if false, then false. And this is one of those weird things where that turns out to be true. Remember, for the if P then Q statements, the only combination that would result in false is if you had T and then F. So it's a little weird, but that is true. And in fact, something that we discussed before is that if P is false, if that first statement is false, then if P then Q is automatically going to be true. So in other words, if we were looking at this problem and we recognize that Tuscaloosa is not the capital of the US, then that would be enough for me to know that the whole sentence is going to be true, no matter what. Okay. All right, so now let's look at an if and only if statement. So we've got tomorrow is Friday, if and only if today is Thursday. Now, the truth value of this statement is going to depend on what day it is, or of the individual statement, sorry. So, for example, at the time of this recording, it is not Friday. And it's not, wait, no. At the time of recording this video, it is a Friday, and so tomorrow is not going to be Friday. But, that changes depending on what the day of the week is right now. However, what we can say is that either both of these statements are true or both of these statements are false. In other words, both statements say or suggest the same thing. Okay, so if today is Thursday, then tomorrow is Friday. And if today is not Thursday, then it would also say that tomorrow is not Friday. So these are both true or both false. And what we said about if and only if statements is that if they both say the same thing, then the if and only if statement is true. Okay. Now, just as a reminder of what this statement means, I don't think if and only if is something that we say very often in just regular English. What the reason that we have the double-sided arrow for the if and only if is because the statement goes in both directions. So what this says is that if tomorrow is Friday, then today is Thursday, and that makes sense as a sentence. And it also goes in the opposite order. If today is Thursday, then that means tomorrow has to be Friday. And that also makes sense as a sentence. Okay. And so if I scroll back up to the top, here we go, that is why we have that double-sided arrow for the if and only if statement, because it's a sentence that goes in both directions. Okay. All right, so let's scooch on back down. So the next problem is going to be about those 4 different statements, the conditional, and then the converse, inverse, and contrapositive. And so here's the following statement. I will be alert at 5 a.m. only if I drink some Starbucks. And they want the converse, inverse, and contrapositive. Now, this is not in the conditional form yet. So first thing we're going to do is write the conditional. And you may have noticed that for this type of problem, we had kind of like a step-by-step format where the first part of the problem was to get the if P then Q form. And then once you had that, you could figure out the rest of the problem. So I will be alert at 5 a.m. is my P, and then drinking Starbucks is my Q. And so this statement is in the form P only if Q. And I want to write it in the form if P then Q. So I'm going to keep the same order, but I'm just going to put if and then instead. So in other words, the sentence would be, if I am alert at 5 a.m., then I drank some Starbucks. Like that's why I was alert. Okay, so that's the if P then Q statement, and we can use that to get the converse, the inverse, and the contrapositive. Okay, so converse is where you flip the order of the sentence. So I'll put the Starbucks first. So if I drink Starbucks, then I will be alert at 5 a.m. It's probably not a true statement, but it helps, right? Okay, so if I drink Starbucks, then I will be alert. The inverse is where we negate each part of the sentence. So in other words, if I am not alert at 5 a.m., so we're keeping the same order as the first sentence. So if I am not alert at 5 a.m., then I did not drink Starbucks. So that's the inverse. And then for the contrapositive, I'm going to take that original if P then Q, flip the order, and negate each part. So if I did not drink Starbucks, because I'm doing the Starbucks first, if I did not drink Starbucks, then let's negate the first part. I will not be alert at 5 a.m. Okay. So that's how you do the converse, inverse, and contrapositive. And notice that the exact P and Q kind of changed grammatically a little bit depending on the sentence. So, for example, whether I say I drank Starbucks or I drink Starbucks, those kind of things we change a little bit just so that the English flows better. And that's something that you won't really have to worry about because those questions are multiple choice. So the multiple choice answers will change the grammatical structure for you. Okay. All right, so I just have two more problems I want to go over. So this next one's pretty short. It's just asking about whether two statements are equivalent. And so to figure out whether two statements are logically equivalent, basically what you're going to check for is, did you switch the order and negate the first sentence in order to get the second sentence? And if you did, that means that you have equivalent statements. So we've got, if my husband remembers my birthday, then I will be happy. And then we have, if I'm not happy, then my husband did not remember my birthday. So if we look at these two sentences and compare them, notice that in order to obtain the second sentence, we switch the order. We put the happy part first, and we also put nots in, so we negate it as well. So we obtain the second sentence by switching order and also negating the first sentence. And so in other words, what this says is that we have the conditional statement and then we have its contrapositive. And if you remember again on that first page when we went over all the different stuff, all the different vocab, we said the conditional and the contrapositive are equivalent. So these two sentences are logically the same. They'll have the same truth values. Okay, so if you switch order and negate between the two sentences, that means they're equivalent. Otherwise, they are not equivalent. All right, so I've just got one more question, and it's about the Euler diagrams, and we're going to determine whether this argument is valid or invalid. So we'll assume the first two sentences are true, and then see if that gives us a logical conclusion. So for these problems, we start out with a box, and then we draw some circles based on the sentences. So the first sentence is that all Disney movies are children movies. So again, we're assuming that these hypotheses are true. That might be arguably false at this point. I don't know. I can't even keep track of all of Disney's movies at this point. But we're going to assume that all Disney movies, so here's Disney, are children's movies. So the Disney movies are a subset of all children's movies. Okay. And the second statement is that Shrek is a children's movie. And the conclusion that we're drawing is that Shrek must be a Disney movie. Now, before I finish that picture, let me clarify something about the placement of the dot in these kinds of problems. So where, in other words, where do we put Shrek in this picture? And what we're going to do is either we're going to confirm that the conclusion must be true. So we're either going to show that there's only one place Shrek can be, and we're going to put it there, or we will place the dot so that we illustrate how the conclusion may be false. So either we put it in the only place it could be and confirm that the conclusion must be true, or we're going to illustrate that the conclusion may be false. Now, if Shrek is a children's movie, all we really know is that it has to be in the children's circle somewhere. But it does not have to be inside Disney. So Shrek can be out here somewhere. Okay, so Shrek is a children's movie, but that doesn't mean that it has to be inside the Disney circle. And so what this picture illustrates is that Shrek could be outside the Disney circle. It doesn't have to be inside. And so this argument is invalid. Okay, so we've illustrated with our picture that Shrek doesn't have to be a Disney movie. So it's an invalid argument. Okay. So, like I said, this is not a comprehensive review, but we've definitely gone over a lot of the most important types of problems. Okay. So, good luck on the test.